Hello everyone. Here is a application of data science for the FIFA World Cup 2026. So here we have made an attempt to make the predictions, and we are using NumPy Pandas data cleaning, transformation, triangle visualization, and pivot table techniques in Colab to predict the winner of 2026 FIFA World Cup. And looking into this cell it performs several initial steps to set up a data set for analysis. It starts by importing essential Python libraries like NumPy for numerical operations, Pandas for data handling, Matplotlib and Cbond for plotting, and standard scaler for data scaling. And then it sets up the plotting environment and defines a dictionary named data containing various attributes for football team like team, region, yellow, goals, squad value, average, and World Cup wins. So this creates the primary data set that will be used for further analysis in the notebook. And to answer the first question, collecting the data set from any source code and to upload in the Google Colab. So these lines are required. So here what is happening is we are taking the CSV file and we are completely saving the data. Then to answer this question, to create an NumPy arrays and perform join, split, search, sort, indexing and slicing operation for the data sets, we need these steps. So here what is happening is several fundamental operations using the NumPy library on a numerical array is happening. It first extracts the ELO column from the data frame DF and converts it into a data file array named ARR. Then it performs the operations like it's printing the original array, that is displaying the initial array. Then it joins or concatenates the array with itself, creating a new longer array. And then it splits the array into two equal parts. And here what it is doing, it is searching the array and return the indexes where values are greater than 1800. And then it is doing the sorting of the elements of the array in ascending order, and then it is doing the assessing of the first element of the array using the indexing concept. So array 0 within the bracket means the first element is accessed, and then it extracts the first three elements of the array using slicing. Here we use array colon 3, that means the first three elements of the array are getting extracted. Then moving on to the answering of the third question, create pandas data frame and explore the series and the data frame operations. So here in this cell we quickly understand the structure and content of pandas data frame by performing the data analysis step. So what is happening here is it imports the display function which is often used in environment like Google Colab or Jupyter Notebook to give rich output more neatly than a simple print statement. So here what it is happening is this display df.head shows the first 5 rows of the data frame. It's a quick way to get a glimpse of the data and verify that it is loaded correctly. Then this df.info, it provides a concise summary of the data frame, including the number of entries, total number of columns, the data type of each column, the number of non-null values per column, and memory usage. And it helps in understanding the data types and completeness. Then moving on to this line, display df.describe, it gives us the descriptive statistics for all numerical columns in our data frame. It includes the metrics like count, mean, standard deviation, minimum, maximum, and quartile values, giving the statistical overview of data distribution. And coming to this code display df team, it displays only the team column from the data frame. The double square brackets indicate that you are selecting a data frame rather than the pandas series. So coming to the next segment, to do the data selection, re-indexing, and the drop-in entries for the FIFA World Cup 2026 data. So as said earlier, the first line imports the display function, which is often used in environment like Google Colab, and gives us the output in the formatted way than a standard print statement. And here we are using display df team, df.z, and df.drop. And this df team, it selects and displays only two specific columns from the data frame, team and elo. Using double square brackets allow to select multiple columns and return a new data frame containing only the two columns. And this display df.set changes the data frame index. Instead of the default numerical index 0, 1, 2, it sets the team column as the new index. This is useful for making T names the primary identifier for each row, which can be convenient for lookup and alignment. This set underscore index by default returns a new data frame with the updated index, leaving the original data frame unchanged. And then coming to this df.drop column, it removes the average underscore average column from the data frame. The drop method is used to drop a column, and this drop returns a new data frame without the specific column by default, leaving the original data frame intact. And coming to the next question, applying the alignment, tracking, and sorting for this data. This df rank, this is a key operation. It creates a new column named rank in data frame df. It calculates the rank of each team based on their elo rating. The ascending is equal to false argument. It means that the highest elo rating will receive the lowest rank. That is rank 1 for the highest elo. And then this line, it prints a descriptive header and then displays a new data frame containing only the team and their newly calculated rank column, showing the teams entered by the elo rating. And this line print, it simply prints a separator line for better readability in the output. And then this display df sort values by goals, ascending is equal to false. They display the entire data frame, but this time sorted by the goals column in descending order, ascending is equal to false, and this allows you to easily see which teams have scored the most goals. And coming to the next cell, with the operations on statistics and hierarchical indexing, the first line, it is useful to get us the correct output in a formatted way. And then this print mean values. What does it do is, this section, it finds the average of all numerical columns in data frame, the numeric underscore only. is equal to true argument. It ensures that only columns with numerical data types are included in this calculation, ignoring any text or object column. The results are then displayed, giving us the quick summary of the average values for metrics like ELO goals, squad value, average value, and World Cup wins, etc. And then the next line, print data state with multi-level index region team. This creates a new data frame with a hierarchical index. It sets both the region and team columns as the index, meaning that each row can now be uniquely identified by a combination of its region and team name. This is particularly useful for grouping data and performing operations on specific subset defined by these multiple levels. And this set underscore index, it creates a new data frame with a specific index, leaving the original data frame unchanged unless in place is equal to true is used. And the next segment is to clean the data set by handling the missing values, outliers, and anomalies. And df dot log2 comma goals is intentionally introduces a missing value np dot nan into the data frame. It sets the goals value for the row at index 2. In the current data set, Argentina is the country seen, and this is done to simulate the real world scenario where data might be missing. And then this df dot fill na, what it is happening is the fill na method is used on the goals column. It replaces all np.ran values with the mean of the goals column. In place is equal to true. It modifies the data frame directly rather than returning the new one. And then there's the print data set after handling missing values. They print the header and then display the data frame after the missing goals value have been filled. And then this Q1 and Q3 calculate the first quartile and the third quartile for the squad value column. These values are crucial for identifying the outliers. And then IQR is equal to Q3 minus Q1 calculates the interquartile range, which is in the range between Q1 and Q3. This IQR is a measure of statistical dispersion and commonly used in outlier detection. And then this print, this line, what does it do is it display the calculated Q1, Q3 and IQR values. And this clean underscore df, here what is happening is this is the core of the outlier removal using the IQR method. It creates a new data frame called clean underscore df that includes only the rows where the squad value falls within the acceptable range defined by Q1 minus 1.5 into IQR, and any values outside this range are considered outlier and are excluded. And finally, these lines are used to print a header and then display clean underscore df, which is the data set after both missing values have been handled and outlier and squad value have been removed. And coming to the next operation on the string manipulation, binning and standardization, this df team, it performs the string manipulation. It selects the team column and applies the string upper method to convert all team names to uppercase. This can be useful for standardization, test data, or ensuring consistency. And then this df category td.cut is an example of binning or categorization. It creates a new column named category based on the squad value column. The td.cut, this function is used to segment and sort data value into bins. So here in bins 0, 950, 1100, 1300 defines the intervals for the categories in the range. And this labels low, medium, high assigns descriptive name to this bin. So the teams where the squad underscore value between 0 and 950, inclusive of 950, are labeled low, and between 950 and 1100 are medium, and so on. This converts a continuous numerical variable into an ordinal categorical value. And then we have the concept of scalar. These lines perform the standardization or the set score normalization. This standard scalar initializes the scalar object from the Skyline.preprocessing library, and then the scalar fit transform calculates the mean and the standard deviation of the yellow column fit, and then transform each yellow value by subtracting the mean and dividing by the standard deviation. This results in a new column called scaled yellow, where the values have a mean of 0 and a standard deviation of 1. Scaling is crucial for many machine learning algorithms that are sensitive to the scale of the input features. Then finally we can print a descriptive header and then display a subset of data frame showing the team in uppercase and the newly created category column and the scaled yellow column, allowing to see as the transformations. Then coming to the merging, concatenation, reshaping, and the pivoting concept. So to create an extra data frame, here we use extra period of data frame with the different team names and coach names. This creates a new data frame, and we can also combine different data sets. And here we use the left join concept, and pd.merge is used to combine the main data frame with the extra data frame. This on is equal to team specifies the merge should happen based on matching values in the team column, and house equal to left indicates a left join. This means all rows from the left data frame will be kept and matching coach information from extra will be added. If a team in data frame does not have a match in extra, the coach column for those will show a NaN value. Then we can see concatenating the data frames, and this pd.concatenate is used to stack data frame or series along a particular axis. Here it is used to combine the first two rows df head 2 with the last two rows df tail 2. This creates a new data frame that vertically stacks and these selected parts of the original data. And then reshaping the data is done with this melt instruction, that is from wide to long format, and this pd.melt transforms data from a wide format to a long format, and this id underscore was team. This specifies the team as the identifier variable which will be repeated for each measure, and then this value underscore was elo goals specify the columns elo and goals that you want to unpivot. The result is a data frame where elo and goal are stacked into a single value column with a new variable column indicating the original value was elo or goals. This format is used to plot a certain type of data analysis. And then to create the pivot table, df.pivot table with the values of goals, region, and sum are given. And this AGG functions within quotes sum, it specifies the aggregation function to apply. In this case, the summing the goals. The output is a table that will show the total goal scored for each region, providing the quick summary of the data. And coming to the next segment of different plots like line plot, bar plot, histogram, box plot, and scatter plot. This plotted figure creates a new figure with specified size this plot. It generates a line plot. It displays each team on the x-axis and their corresponding elo rating on the y-axis with circular markers at each data point. And this plot dot title, plot dot x label, plot dot y label. It set the plot title and axis label for clarity. And then this plt.grid to adds a grid to the plot, making it easier to read values. And plt.hstring rotate the x-axis label by 45 degrees to prevent overlap. And this plt.type layout adjust the plot parameters for a type layout, preventing labels from getting over. And this plt.show, it displays the generated plot. Similarly, the other plots can be generated. The different type of plots are bar chart, and in this bar chart, titles label, x-stick rotations are applied, and plt.show, it displays the chart. And similarly, the histogram, the squad values are picturized, and in box plot the average age of the players are displayed, and in the scatter plot the elo versus goals displays are done. And this plots, it gives a visual overview of the data set, key numerical variables and their relationship, and they are useful in the exploratory data analysis. And coming to the next concept of generating the advanced visualization. So here we use SNS pair plot. This line generates the pair plot. A pair plot creates a grid of plots where scatter plots are shown for every possible pair of numerical variables: elo, goal, squad underscore value, average underscore value from the data frame. These scatter plots, it helps us to visualize the relationship or correlations between each pair of variables. And these histograms are shown on the diagonal of the grid. These plots display the distribution of each individual variable, providing insights into their frequency and spread. This plot dot show displays the generated plot. And coming to the next topic on creating the pivot table and analyzing the summarized data. So this course uses the pivot table function from pandas to create a summarized table. It calculates the total goals and World Cup wins for each region by summing up the values. The pivot table takes values to specify the columns, to aggregate index to define the grouping column, and aggregate function to set the aggregation method here, the sum. Finally, it brings the header and then uses the display to show the resulting pivot table in the output. So, from this analysis, we have found that France has the highest elo rating, and this Brazil has the highest World Cup wins, and this elo rating and goals, they indicate the team strength. And the conclusion what we can do here is by using the data science techniques such as NumPy, Panda, cleaning, visualization, pivot table, FIFA team performance can be analyzed. And the France is predicted as to be one of the strongest player for the FIFA World Cup 2026, and we are supposed to wait and watch who will win FIFA World Cup 2026. And the references are from these sites. Thank you.